These are notes on ionic compounds, and it's section 7.2 in your book. We've already looked at how ions form, so now we're going to look at how they bond together to form compounds, which are called, so the bond between ions are called ionic bonds, and they make ionic compounds. Ionic compounds. So ionic compounds bond metal, which we talked about are positive ions, to nonmetals, which are negative ions. There are some exceptions to this, and so we'll talk about those as we talk about polyatomic ions. The more overarching principle is that a positive ion will bond to a negative ion. Sometimes you get a positive ion that's made completely out of nonmetals, but still is an ion. So we'll talk about how that works a little later. It's a result from an attraction between oppositely charged ions. And what happens is the atoms become ions first, and so they lose or gain electrons, and then they're electrically attracted. Remember, then you have a positive and a negative, and positive and negative attract. Going back to that whole idea of electrons attracted to the nucleus of an atom. So that's what forms an ionic compound. Compounds are neutral. They have to be neutral. Otherwise, say you have a pencil, for example, that wasn't neutral, it's going to stick to something else that's not neutral. A good example is those of you who've taken a balloon and you rub it against your head and stick it to the wall. You've taken a neutral balloon and polarized it, essentially. You've given it a charge, and now that gives the wall a charge, and then the balloon sticks to the wall. Well, that's something you forced to happen, but imagine anything were charged. Clearly that would be a world that would be very difficult to live in. So atoms need to form compounds in order to cancel their charges. You've got to have neutral compounds. One of the things to note, and this is true of ionic and covalent bonding, and we'll talk about covalent bonding in a couple weeks, when atoms bond, they lose their properties and they gain new ones. And this might be self-evident to some of you, but I feel like it needs to be said. So if we look at sodium, for example, sodium's a metal. It's shiny, it explodes in water, and it's so soft you can cut it with a knife, like a butter knife. Properties of chlorine. Chlorine is a gas at room temperature. It's green. It's highly poisonous. When sodium and chlorine bond, they make salt, table salt. It's not shiny. It doesn't explode in water. It's a necessary nutrient. It isn't green. So the properties that sodium and chlorine had are not in any way related to the properties that sodium chloride has. If there's any coincidences, that's just what they are. So for example, sodium is solid at room temperature, so is salt. That doesn't mean the sodium's more powerful than the chlorine or anything like that. It's just a coincidence that salt happens to be solid and sodium's solid. So keep that in mind. Just because a certain atom has a certain property doesn't mean the compound that has that atom also has that property. So, as we talked about, positive and negative ions are electrically attracted. So, if we have an Na plus and a Cl minus, those two are going to attract together, and they're going to make NaCl. Notice we don't put the charges in because now it's neutral. We've neutralized one another. Mg2 plus and CO3 2 minus, 2 plus and 2 minus, those two are going to attract electrically, and you're going to form MgCO3. And just to kind of review, MgCO3 means there's one magnesium, one carbon, and 3 oxygens. Even though the CO3 had the charge on it, that's still made up of one carbon and 3 oxygens. So remember, the subscript tells you how many of each element you have. That may be new to some of you. I expect you do know that though. So if you didn't, write that down. The subscript talks about the element in front of it. So positive and negative ions, as we said, must cancel each other to form a bond. So Li plus cancels F minus, and you get LiF, lithium fluoride. But let's say you have F minus and Mg2 plus. Then you're going to need 2 F minuses, and you get MgF2. Let's say, on the other hand, you have two 1+ charges and an O2 minus. That would work because then you have plus plus is 2+ and O2 minus, and you get Na2O. Let's say we get really crazy and we have like aluminum 3+ and O2 minus. One of the ways you can look at this is you're looking for the least common multiple, which is 6. 3 times 2 is 6. 2 times 3 is 6. And so those come together, and they don't exactly line up. This is just my PowerPointy way of showing that. And you get Al2O3. So you can see how in each case, the ions are forming together to make a neutral atom. Now, I just said they don't exactly line up, so let's look at what happens. When ionic bonds form, they make what's called a crystal lattice. Whoops, let me get back there a second. And I'm going to want the pen here. So they form this lattice, like this structure, and on the top here, these top 3 pictures are all just different versions of a sodium chloride bond, so table salt. And when we're talking about sodium and chlorine, or when we're talking about ionic compounds, we never talk about one compound. There's no such thing as a compound of salt. Molecules are different. We can talk about a molecule of, say, sugar, which is a covalent molecule. But because ionic bonds form this lattice structure, like a crystalline structure, you can't just isolate one, kind of quote, compound. What we do talk about are formula units. And if you notice, for every chlorine, there's a sodium. And so then we would say that that together is one formula unit of sodium chloride. So kind of let that sink in. Now, this compound down here, don't worry about what it is, but I wanted to show you a picture where this is clearly not 1-to-1. There's more of the little white guys. Those are actually sodium. We can put that in if you're curious. And the yellow ones are sulfur, so this is sodium sulfide. But there's clearly more than one sodium per sulfur. And this is going to form a different shaped crystal. This is why different crystals are different shapes. It depends on the ratio of the ions in them. So, and here you can, I don't know if you can tell, but there's actually 2 sodiums for every 1 sulfur. And so that would be Na2S. And then this whole thing together would be one formula unit. So please feel free to put any questions on the comment section and come to class ready to work with ionic bonding.